Dear participants, in this session, we will go for experiment number 9 of section 2 IAVOC 105, and this section corresponds to the electrical technology coursework of the theory part. Now this session will be dedicated to the study of three-phase induction motor characteristics. We will be using a squirrel cage type induction motor in our case, and the particular trainer that will be used is NVIS 7006 three-phase induction motor trainer. Here we will be performing two experiments. One, the first one in which we will just run the motor and reverse the direction of rotation of the motor. We will see how it is actually done, and also we will have a close look at phase to phase voltage and line current, that is current in a single phase. Here I would like you to compare the value of current in a single phase with that of the operational current of a single phase induction motor, and then you will appreciate why three phase induction motors are always preferred over single phase ones when you have the application demand. In the second experiment, we will be working on no load test of the induction motor, where we will determine the power factor. Now you see, this is the actual view of the trainer. We will have the real view also. Here again I will be using two different cameras. One camera to show the entire trainer, and the other camera to have a close look only on the front panel, so that we can have a better view of the readings given by the meters. Okay, I think that's better. Yeah. Now you see here that this is the front panel or the control panel for the motor, and this is the motor. I will separately show the terminals that are available with the panel as well as the motor. There is a brake drum arrangement, and through this spring loading mechanism we can load the motor at per the experimental necessity. Now let us look into the front panel of the trainer. We can see here there are three lamps R, Y and B indicating three phases in operation. There is a three-phase MCB, and this is the three-phase output when the MCB is charged. Now you can see definitely this is a star connection simply, and next there is a voltage block terminal, current block terminal, or we can say voltage measurement block, current measurement block. These terminals will be actually used for measuring the voltage and current. And the third block of the terminals, that is used for involving the wattmeters in the circuit. And finally there is the output terminal to which we have to connect the rotor. If we simply want to start the motor and observe the rotation without any interest towards the voltages and current of line or phase, whatever it is, then we can simply connect this terminal, that is the output of the MCB terminal, to the motor input terminal, and the motor will work, no doubt. Now you see here that this is the terminal at the motor head. Again, this is a star connection, and you can see this R, Y and B are also present here. You will be asked to compare the fuse values in case of the single phase motor. In case of the single phase motor that we had used for experiment number 8, you could find that both the stator winding and run winding, they had 10 ampere fuse, but here the fuse is having the value of 3 ampere only, which itself suggests that we need lesser value of current for each phase here. Now let's go for the technical specifications. The three phase main supply is 400 volt and its line frequency. The type of the induction motor is squirrel cage motor. Three phase, the RPM is 1440 with some tolerance, tolerance on both sides. Class B insulation is given with the motor. Now whatever the meters they have been used are for this, in our case, since we have a single HP motor, that's why the ammeter is capable of 0 to 5 ampere, the voltmeter is capable of 0 to 500 volt, and the wattmeters are 0 to 1000 watt capacity. The MCB has been used with 10 ampere rating, and then again, if you have gone through the video of experiment number 8, then there is needless to mention, but still I would like to mention that whenever you are performing any experiment or any work with electricity, please remember that there are three words. First is safety, second is safety, and third is safety. Therefore, be very careful to maintain all precautionary measures. You must stand on a rubber mat, or if it is not given, then use your rubber soled shoes invariably while performing the experiments or work. Another thing that I would be very keen to let you know, that first go through the theory of what you are going to do or what is you are expecting out of the experiment. Accordingly, then you will be able to build a correct circuit. Otherwise, just to look at the circuit diagram and trying to build the circuit and putting the switch on to see the motor rotating or the lamp glowing, there is no goodness of that. In that case, you may commit some mistake that you will be unable to know because you do not know the theory. That might cause a damage to the machine, and more severely that might hurt you. And since it is electricity, such type of danger or such type of accident can result to fatality itself. Therefore, we should be very cautious. What we do not know, we should not do. There should not be any horseplay. We should be careful. And another thing that you should remember, that while performing such experiments or work, never do it alone. Let at least be one person there with you. So if there is some problem to either of the persons, the other person can save him from the situation. So these things you need to remember before performing any practical or any experiment in the electricity lab. Now you see here in the manual a very detailed idea of different hazards that can happen with while handling the electrical equipments they have been given. I suggest or I strictly advise that you should go through them. Be very careful to read each and every line. Now you see in the electricity lab, you will also find the nearby hospital and ambulance numbers so that if some untowardly event happens, you can immediately let the concerned authority know about it. Definitely the teachers will be there, but still all those informations are there displayed in the lab very loudly. Before the ambulance or the doctor or the health person arrives, what first aid measures you should take, that has also been given in this manual very neatly. Another thing that you have to remember, that while performing any operation with in electrical lab, you must ensure that the earthing is proper and it is healthy. If the earthing is healthy, many accidents can be averted. That is also very safe for the equipment that you are using. And here you can find that what are the standard voltage that is expected in between phase neutral, earth and neutral, and in case of a three-phase supply, everything is given. Therefore, I advise you time and again, go through the manual vividly, meticulously before you perform the experiment. Now you see here the internal construction of a three-phase induction motor. Typical constructional features have been very appropriately provided here, and their working, basic principle of working has been given. Important formulas they are given. Then very importantly, you can see the methods of starting of induction motor, like DOL starting, star delta starting, they have also been provided. One important concept is there about induction motor, which is slip, that is always present in an induction motor because it is never able to follow the, or it is never able to rotate at the synchronous speed. The slip is always there. So everything is given. The characteristic of the this induction motor, that has been appropriately detailed. And remember that unless you go through all these things, don't ever expect that you will be allowed in the electrical lab. You must be able to answer these questions, and then only your passport to the electrical lab will be there. So therefore, be very careful to know about this. Definitely, all these things have been taught in your theory syllabus, but it is important that you have a recap of your knowledge with this very concise document that has been provided in this manual before you enter the lab and perform the experiment. Now see, for experiment 1, our objective is very clear. We have to run the motor and we have to reverse the direction of rotation of the motor. So in one case we have to run the motor in clockwise direction, and in the other instance we need to run it in anti-clockwise direction. So here the connection diagram has been given, but as I have already suggested you that you should look at the circuit diagram first. Here you can see this is the circuit diagram that we have to make. Now for the experiment number 1, this is for no load test. We need not to involve the watt meters. Rest of the circuit is alike. So you see here the basic thing is very clear. We need to run the motor. We need to measure the voltage between two phases, and we need to measure current through one of the phases. So let's now build the circuit and see how we can change the direction of rotation for the motor. So let us go to the camera view, and here we have to make the connections, and then we will charge. That means you can see here when I put on this MCB, the R and B, actually the Y lamp, it has developed some problem, that's why it is not glowing, otherwise this phase is also very healthy. Now you see that we will connect the circuit so that we can involve the voltmeter and ammeter for our measurements. The voltmeter will be employed to measure voltage between R and B phase, that is R and blue phase, and we will be measuring current in the R phase. So let us now go for the closure view. Okay, so let us start the wiring part. Unfortunately, I couldn't locate the blue jumper wires. Therefore, this is a problem of 5S. But anyway, I will be using black wires in case of the blue phase. Okay. I hope the things are clear to you. And you can see that I will be directly connecting this output of this mains, that is red phase, to this point. I have to measure the voltage. For that, I will be employing the voltmeter in the circuit. Now, I am to connect other terminal of the voltmeter. For that, as I had already told you, I will be measuring the voltage between red and blue phase. Therefore, this blue phase is used, and this completes the connection for the voltmeter. Done. Now let us go forward and connect the ammeter into the circuit. So this is that, and I will further go. Okay, this will fall a bit short. Use this. So fine. From ammeter, I have directly connected to the rotor supply, and now the ammeter will be called for the circuit. And now you can see that we have made every connection for the red phase. Now let us go for the yellow phase. You see here I will be directly connecting because this yellow phase is not used for any further measurement. So you can see that it is connected to the stator connection that is going to the motor. You can see this star connection is being applied to the stator of the motor. Therefore, the rotor rotates. Okay, because this three phase that actually produces a rotating magnetic field at the stator, which ultimately through the effect of induction that compels the rotor to rotate. Now finally, you see here we have made the blue phase at connected to this terminal. So I will be taking output from this terminal here. And finally, I will be connecting these wires. You can see I will be just changing the camera. These wires I have already taken from the motor stator heads, from the motor panel itself. So here you can find this is one, this is another, and these are the things. So I will closure view. You can see here now three connections have gone to the motor. Now we will start the motor. Now you can see here the motor is rotating. You can see the brake drum. I will stop it again. I request you to kindly note the direction of rotation. You can find in this case the rotation is counterclockwise. Okay, this is clockwise, sorry. Yeah. Okay, let us now go for the readings. You can see here the phase to phase R and phase B, in between them there is 424 volt and the current is 1.9 ampere only for red phase. Now this is very much a balanced load, therefore you will find same current in every phase. Alright, now remember that if I want to change the direction of rotation for the motor, if I want to change the direction of rotation for the motor, what I have to do? Simply interchange any of the phases. Alright, we will do that. You can see I will interchange these two phases. Now you will see the direction of rotation for the motor. I will off it. Now you may find the direction of rotation has changed. This is counterclockwise direction. So therefore it is important to remember from these observations that if we want to change the direction of rotation of a three-phase motor, you need to simply interchange one of the phases, right? So now we will go for the next part, that is block rotor test, experiment number 2. Remember here that we can do some very dangerous observations. If the rotor is rotating like this and if I remove one of the phase, the motor will not stop here immediately, but that will put tremendous load on the other phases. You can see here I am removing this phase. Now what will happen? That the other two phases will get loaded. So this single phase problem is always there in the motors or the that are used for driving the pumps in borewells in agricultural fields. Okay, so now we will be going for the second part. Now in second part the things will be a bit clumsy, because we have to involve two wattmeters in the circuit. All right, because we have to take the effective power of the load, and since this is a balanced load, we can very well use the classic 2 wattmeter method for determination of the power. As you have already studied about the concept of 2 wattmeter method, I will not detail on the same, but I suggest you that you kindly go through your theory and practice again to be perfect about the concept of 2 wattmeter method of measurement of power. Now I will go for the closer view. Now I will make some rearrangements here. Here I had taken the ammeter directly to the stator connection. That I am to remove. Simply what I am to do, I am to make this connection so that the current coil for first wattmeter, this is the current coil for first wattmeter, this is inside the circuit. Maybe I will be using a shorter jumper wire, and then I will use this one for this. This is a longer one, and this is that. This is the terminal for the pressure coil. So the first wattmeter connection is ready. We have just involved this connection from ammeter. I have given to the wattmeter connections, and from then I am going to the stator. Now for the second wattmeter, I will be using the blue phase. So here, what I am to do, I will remove this connection. So now you can see this stator is no more connected directly to the three-phase output from the MCB. So here I will make a connection to the current coil. You can see it is going to the current coil. From here I will be giving to the stator connector. Then we will give the connections to the wattmeter, and finally the pressure coil will be involved in the circuit. I think everything is clear and it should operate. Now you see the motor is rotating. I will stop the motor. I will run the motor again, and you can get the values. You can see here there is some problem with the cam. Okay, there is some problem with the cam, so I will go for the front cam itself. You can read very easily that the voltage value is 424. The current value is 1.88 or 87. Both the wattmeters, as we had well expected. They are giving the same reading, that is 102 watt. Okay, I will again put it off. I will put it on. 424 is the voltage value phase to phase. Phase line current is 1.87. The wattmeter reading for both the wattmeters 102, 102 watt. Okay. So now let us go back to the manual. Here we can see that in the second experiment we were supposed to do no load test. Therefore, in the brake drum arrangement we had not applied any load. You can see here, this is the spring load arrangement through which we had applied no load to the drum, and we have performed the experiment. And now you can see that the voltmeter reading you have to note, the ammeter reading you have to note, the wattmeter reading, first wattmeter you have to note, and second wattmeter you have to note. The no load input power is nothing but the addition of the two wattmeter values, from which you can simply determine the power factor, that is cos phi, by using the formula total power, as you can determine by the wattmeter readings, divided by under root 3 multiplied by voltmeter reading and ammeter reading. So this is assignment to you to determine the power factor, and that is all with your three-phase motor characteristic study. If there is any confusion, you are requested to kindly post it in the comment box. Thank you.